Hello friends, today we are going to discuss about the ping and the packet flow. Whenever we initiate the ping, what are the packets generated, and we are going to see how those packet travels. This ping is a very useful tool. Basically, it helps us to check the connectivity from one endpoint to another endpoint. Maybe we can rename it as source and destination. At present, my PC is the source and the destination is google.com. I do have the reachability. That's it. If I'm going to disconnect my Wi-Fi, I'm not going to get the reply. I'm going to get some other messages. Now we are going to discuss three different scenarios. This is scenario 1, same VLAN. And then we have scenario 2. In this we have a single router, and then we have scenario 3. Here we do have 2 routers. Let's go back to scenario 1. So guys, we will be finishing these scenarios theoretically, and then I'll show you the same demonstration in GNS3. We all pretty much know about the encapsulation and decapsulation process. In my PC, I initiated the ping. Alright. After the transport layer, we get packet, and in data link layer the frames are getting added. So this is the encapsulation process: segment, packets, frames, and finally it gets converted into bits and bytes, and it goes through an electrical wire, and then it gets decapsulated. On the decapsulation side, in each and every layer, when the packet flows up, each and everything is going to get stripped out like this. During this ping process, there are 4 major packets are involved. The first one is frame header. This is the PDU of layer 2. And then we have IP header, ARP header, and icmp header. Now we are going to discuss how these packets are generated and what are the fields gets populated. This IP header and ARP header will not be present at the same time in the type. This is the field which denotes which packet is encapsulated. So if you see 0 into 800, that is IP, and if you see 0 into 806, that is ARP. Now when we initiate a ping, the destination MAC, source MAC, everything's are getting populated. To understand about this process, I do have prepared a flowchart which will be very helpful. So let's say my source PC IP is 10.0.0.10, and from this PC I'm pinging any destination. Let's say I'm pinging 20.0.0.1, that is my destination IP. So what is going to happen first? In the source PC, the AND operation is going to take place. The AND operation is going to contain 2 things. First, the PC will do the AND operation between the source IP and the source mask. It is going to get result 1. Similarly, it is going to do another AND operation for destination IP, and here it uses source subnet mask itself. You will get the result 2. Now PC will do a comparison between this result 1 and result 2, and it will find out if they are in same subnet or in a different subnet. If they are in the same subnet, let's say your source IP and your destination IP are in the same subnet, next it is going to check for the ARP cache. See, all of these processes is going to take place only on the source. Alright. If you want to check the ARP entry in a PC, you guys can use this command. This is for Windows. ARP space -A. That command will tell you the ARP entry. Now after the AND operation, the source PC found out they are in the same subnet. It is checking the ARP cache. ARP is present or not. Now what is the purpose of this ARP? ARP is nothing but it is going to tell you the corresponding MAC address for an IP. Let's say you have pinged 10.0.0.20. Now, in order to send the ping packet, in order to send the ICMP packet, the destination MAC should be present in your ARP table. While checking the ARP cache in the source PC, there are two possibilities. The ARP might be present or it may not be there. It may be empty. If it is there, then the source PC, the source is going to send the ICMP echo request to the destination IP. Alright. Once the ICMP echo request is sent, then we are going to receive a ICMP echo reply. And based on the ICMP codes, you can determine if it is a success or failure. If ARP cache is not present, the other scenario, it is going to send ARP request to the destination IP. So what does ARP request contain? Hey, who has 10.0.0.20? Or you can replace it with any destination IP address. It is simply going to ask the question. And if it receives the ARP response, it is going to send the ICMP echo request. So here's the thing. ICMP echo request can't be sent to a destination without having the corresponding MAC address. What if ARP response is not received? Obviously, it's a failure. Alright. So in this PC1, let's assume A, B, C, D are the MAC address of these PCs. On PC A, I initiate a ping 10.0.0.4. Now what PC will do? First, it is going to do the AND operation and it will try to find out the source and destination are on the same subnet. Of course, they are on the same subnet. Next, it is going to check the ARP cache. Since this is a new ping, PC A doesn't know the corresponding MAC address of its destination. Alright, so this is how your frame structure looks like. Your destination MAC, it is going to be FFF, and your source MAC, you know your source MAC. A. In your IP header, you will see source IP is 10.0.0.1, destination IP is 10.0.0.4. See, you don't know the corresponding MAC address for 10.0.0.4. Now what PC will do is it will initiate a ARP request. This ARP request travels from this PC to
PCD. Here we need to understand what is meant by ARP actually in simple terms. ARP is nothing but it is a question. It is going to ask, hey, who has 10.0.0.4? Now what PCD will do? He will reply with its MAC address. So basically the ARP header has sender IP and sender MAC, target IP and target MAC. In the target MAC value is going to be broadcast again because we are not sending it to any specific destination. So the value is going to be, that's correct, it is going to be all zeros, right? So once PC4 receives this ARP request, it is going to respond. And before that, we need to understand what switch does while receiving this broadcast. So whenever switch receives this broadcast, it is going to send it to all connected ports excluding the originating port. Okay, originating port is nothing but the port where it received the frame. Apart from that port, to all the other connected ports inside the same VLAN, it is going to send. The PCs who are not destined for that packet, they will drop. In this scenario, B and C drops that packet. In the ARP, the question is going to be who has 10.0.0.4. So the PCB and PCC drop them. But this guy, this PCD, what he will do is, hey, I am 10.0.0.4 and he will reply. So once PCA receives the reply, the ping is successful. Let me quickly show you this. You can check the ARP table like this. You can execute the command ARP space -A. If ARP is already present, then there is no point of sending ARP request. Alright, I believe you understood this part, this scenario 1. See, ARP is not the complete thing. Once ARP response is received at PC1, it is going to send the icmp echo request. And now to send the icmp echo request, no more broadcast. It is going to be unique as to PC4. And afterwards, that PC4 will send icmp echo reply.
Now, let's move on to the another scenario. Right now we are dealing with the same subnet. What if the source and destination are in different subnet? Now the PC is going to check, do I have a default gateway configured?
If default gateway is not present, then the packet is going to get dropped. If default gateway is present, then
it is going to check the ARP entry of gateway IP, not the destination IP. ARP present, then it is going to send the icmp echo request to gateway IP. Guys, please compare these yellow boxes. In the same subnet, it is directly going to send the icmp request to the destination IP, whereas here it is going to send to the gateway IP.
If in case ARP is not present, then it is going to send the ARP request to the default gateway IP. After sending the ARP request, it is going to wait for the ARP response. If ARP response is received, then it is going to send the icmp echo request, which was already prepared. If it is not going to receive the ARP response, then it is a failure.
In this scenario 2, we do have a router in between. Now my source and my destination are going to be in two different subnets. In PCA, I have initiated a ping 20.00.10. First step, what it is going to do? AND operation. Now we found out that source and destination are in different subnet. What is second step? It is going to check, do I have a default gateway configured? If there is no default gateway configured, then the packet is going to be dropped. In this case, we do have the gateway configured. What is the third step? Check the ARP caching. Do I have the corresponding MAC address for 10.0.0.1, because 10.0.0.1 is my default gateway. I don't have the ARP caching. What is step 4? Send the ARP request to gateway. So this makes the difference between same LAN ping and a different subnet ping. Within a same VLAN, the ARP request is sent to the destination. The ICMP is sent to the destination directly. But whereas if your destination falls in a different subnet, then your gateway comes into picture. You don't have any privilege to send any packets beyond your gateway. So you should always get help of your gateway. So the ICMP request or the ARP that will be only forwarded till the gateway. And if you guys remember, the basic purpose of a router is to break the broadcast domain. In scenario 1, when the switch received the ARP request, it did broadcast, correct? The same thing happens here. When switch 1 receives the ARP request, it is going to do the broadcast. When the broadcast received at the router is not going to forward it. It breaks the broadcast domain actually. The ARP request sent to the gateway and the gateway replies with ARP reply. So actually it sent the ARP request initially and it sent the ARP reply. And then what happens? Then this PC sends the ICMP echo request to this router. Now what this router does, it has the ICMP echo request with it. Let's quickly stop here and let's quickly have a look at the frame structure so far.
This packet is from PC to the default gateway. Now the frame structure consists of
destination MAC and source MAC. So I don't know my destination MAC, so it is going to contain all FFF. And the source MAC is going to be A. Alright, and your IP header. Your source IP is going to be 10.0.0.10 and your destination IP is going to be 20.0.0.10. Then comes the ARP header. What is your sender IP here? 10.0.0.10. What is your sender MAC here? A. What is your target IP here? In ARP, the target IP is going to be your gateway. What is the target MAC here? You don't know the target MAC, so only you are sending the ARP request. See guys, this is very simple. Out of these three frames, you can also include ICMP. ICMP and IP header doesn't change. It never changes. The IP header remains same.
Because if the destination IP gets changed, then we are not going to reach the destination. The ping will be a failure. This frame header and the ARP header alone changes frequently.
The ICMP header received at the router. Now what is going to happen is, the router is going to check its ARP cache. It is going to check, do I know 20.0.0.10? So now router knows that, okay, 20 is my directly connected network. I know that. But do I have corresponding MAC address for 20.0.0.10? The answer is no. Now what router will do is, it will keep the ICMP header here and it will send the ARP request to this PC. Not to this PC actually. It is going to send the ARP request, and what this switch will do is, it will do broadcasting. Because switch also doesn't know where the C is connected. Now the question is, who has 20.0.0.10? And this is a broadcast message, and switch forwarded it to PC3 and PC4. PC4 will drop it and PC3 will reply. Once it replies, it received at the router. Then router sends the ICMP echo request to this PC. Alright, I hope so far you guys understood. Frame and ARP header changes frequently, but IP header never changes. When you initiate the ping, the source IP and destination IP remains constant throughout the ping process. Now, once the ICMP echo request is received at the PC3, it is going to send the ICMP echo reply. Now what happens? Who is the source now? Only now the source IP and destination IP gets changed. Now your source IP is going to be 20.0.0.10 and your destination IP is going to be 10.0.0.10. Alright. Now PC will check. What it is going to do? It is going to do the AND operation. Is source and destination are in same subnet? No, they are in different subnet. Do I have a default gateway configured? Yes. See, I have a default gateway configured. Now what PC will do is, it will send the ICMP echo reply to its gateway. Once the gateway receives that ICMP echo reply, now router will check. Do I have the ARP entry for 10.0.0.10? It already has, correct? Because whenever a device receives a packet, it is going to do the source MAC running, router switch, same case. Now router will send it back to the PC. That's it. So this is how ping works. I have replicated the same scenario in Cisco Packet Tracer. Let's quickly have a look at the packet flow and the headers. So this is my scenario. This side this is 10 subnet and this side this is 20 subnet. Let's switch to simulation, and I have already opened this PC. So let's check the ARP cache. ARP space -A. It is present. So let's delete it. ARP space -D. Now let's initiate the ping. So I'm let's check the IP address of this PC. IP config 10.0.0.10, and this is my default gateway. Let's ping 20.0.0.10. So this is the other PC which is in my neighboring subnet. So I have initiated the ping. See, at the moment when I hit ping, it generated ARP because it doesn't have anything on the ARP table. So let's quickly have a look at the ICMP. Layer 2 is not populated yet, but layer 3, the source IP and destination IP is present, and the ICMP message type is 8, which is nothing but this is echo request. Fine. Now let's have a look at the ARP. Here, my source IP is this one, and the source MAC, which is nothing but belongs to this PC. And my target IP is, if you guys remember, it is going to be your gateway. Because the PC did the AND operation, the source and destination are in two different subnet. So the PC is going to send this ICMP header to the gateway only. Let's start. Now the ARP is sent out. Let's follow it. And it is sent to the router. Now router is going to send back ARP reply. See, this is, first let's check this one. So your ARP source is PC and the destination is gateway. And from router, it changed. The source IP is router and the destination is your PC. See, this is only ARP request and ARP reply. Once they are received, the ICMP is sent to the router. Let's check the result. See, now router is sending the ARP packet because the router doesn't know who has 20.0.0.10. The ARP is received at the PC and the PC sends the ARP reply. Now the router is going to send the ICMP echo request. If you guys can see here, that's it. So many of you already know that whenever you guys initiate the ping for the first time, the first ping is going to get failed. The other three will be success. Fine. The ping is successful. That's it. So whenever you initiate a ping, first the AND operation is going to take place. Then it is going to find out if they are in same subnet or in a different subnet. If they are in the same subnet, it is going to check for the ARP cache. And if the ARP is present, the ICMP echo request will be sent. See, whatever we discussed with the scenario and whatever we saw in the packet tracer, those things are explained in the flowchart. Please take a snippet and go through this. So if you guys understood this, just comment yes. And if there are any mistakes, please do let us know so that we will correct ourselves and will post the next video based on your feedbacks. All right. Thank you. Have a nice day.